Hello everyone, welcome to Karnataka KCT and Boards, and I'm Diksha Kaushal, your chemistry master teacher. So everybody, let me know in the comment section if I am visible to all of you or not. Yes, students, am I visible to every one of you or not? Very good evening, very good evening. Okay, so today we are going to do PU board a viral paper. So basically, we are going to see a hint of what exactly your paper is going to be. Okay, so are you all ready? Are you all ready for that, everybody? Chalo. Let us try to solve the questions here, right, without wasting any time, right? Okay, chalo. Done. If you're ready for that, visible and audible, yes, ma'am. Very good. Nitro, Samuel, Soumya, very good, very good. Chalo, let us start it. Let us start it. So the first question, as you can see on your screen, students, first question on your screen is, which of the following compound is more reactive towards SN1 reaction? Okay, towards SN1, which is more reactive? First, you need to tell me कि SN1 reaction. SN1 reaction, we know it occurs via two steps, right? Two steps means it will have formation of carbocation. Formation of carbocation. Can anybody tell me formation of carbocation, guys? Formation of carbocation. So simply here what you're going to do, you're going to see the most stable carbocation that is formed, right? Okay. That will be answered from GOC, which is the most stable carbocation. So always the stability of the carbocation is based on Barhi. Okay, what is that? Barhi. Like you eat barfi, na? Barfi. So when you will get good marks in PU and you will say barfi, right? So like that we have barhi. That is back bonding, aromaticity, resonance, hyperconjugation, inductive effect. That is, yes, very good. Now, acha ji, thank you. Which of the following compound is more reactive towards SN1 reaction? So what I can see here, if I take away this Br from here, positive will be on this side. Here, positive will be on this side. Here, positive will be over here. And here, positive will be over here. So, what I can see that maximum stability is definitely is in resonance. Okay. Here also you have conjugation. Here you will have the formation of CH2 double bond CH, this will be CH2, right? This kind of situation you will have here. But you know what? Over here you will have the formation of conjugation. Just one conjugated pair will be there. This double bond will jump here. The electrons will jump here. I can also write it on the next page over here, right? I'll just write it on the next page. Chalo, next page we have over here. So I'll just write it on this page only. Okay? So if you have that kind of situation, that will be C double bond C, this is single. So what will happen? This will jump here and you will have the formation of C single bond double bond and you will have positive over here. But in this case, you will have the formation of CH. This is basically H. This is one phenyl. This is another phenyl, which will cause two resonance here. That is the reason it is going to be maximum stable. So answer is going to be A is the correct answer. Is that clear to everybody? Is that clear to everybody? Understood what exactly we are doing here? Understood everybody? That what exactly we are doing here? They are asking you the stability of carbocation. That is answered by Barhi, back bonding, aromaticity, resonance, inductive, and hyperconjugation. Right? Okay. Next question is beta pleated sheet structure in the proteins referred to. There are alpha helix structure. There are four kind of structure of proteins, right? Primary, secondary, tertiary, and quaternary, right? Okay. So if you talk about the beta pleated and alpha structure, yes, everybody, are they tertiary, primary, dono, secondary, or quaternary? Yes. Yes, everybody. So answer is going to be secondary structure. Okay. Can you tell me what is alpha helix and beta pleated? Basically, alpha helix is this kind of structure like a spiral. Okay. Beta pleated is this kind of structure. right? Both are because of the hydrogen bonding between the bases, right? Okay, that is not hydrogen bonding, you can say between the amino acid. That is about DNA, na, hydrogen bonding. This is basically between the amino acids, okay, between that, right? Alpha helix and beta are to be most secondary structure of protein. As per the protein folds into a three-dimensional structure, the secondary structure form the intermediate structure. Here answer is D. Next is anisole can be prepared by action of methyl iodide on sodium phenate. Okay, here it is sodium phenate. The reaction is called which? Okay, anisole. That means they are asking you this thing. They are saying that you have the formation of anisole with the formation of methyl iodide on sodium phenate, right? Okay, that reaction is called, what's the reaction? Fatigue reaction, Itard's reaction, or Williamson reaction. Very simple. Okay, that is RO. So what is Williamson synthesis reaction? RONA plus you have RX. It will lead to the formation of ROR, that is ether. So the same thing is going to happen here. You will have CH3I, you will have sodium phenate, right? And hence you will have the formation of anisole over here. So answer is going to be C is the correct answer. Okay, answer is going to be C is the correct answer. Next question on your screen is a compound with molecular formula C5H10O. There is a compound which has a molecular formula C5H10O, okay, forms a phenyl hydrazone and gives negative tolerance test and iodoform test, okay. The compound on reduction gives N-pentane, the compound A can be, okay. Pent will be over there. Here you have ketone. Here also you have ketone. Here you have aldehyde. Here you have alcohol. They are saying it is giving negative tolerance test. Negative tolerance test, that means it cannot be an aldehyde, right? Okay. So aldehyde is ruled out, right? Then you have these two are ketones. It is also giving us negative iodoform test, right? That means this thing should not be there, right? So if you talk about pent 2, this is pent, this is 2-one. It has CH3, C double bond O. It has CH3, C double bond O. If it is giving positive, dekho beta. If you talk about tolerance test, it is not given by ketones. So that means they can be ketone. Aldehyde, definitely it will give tolerance test. That's why aldehyde cannot be A, right? Let us talk about this pentane 2-one. This is also not possible because CH3, C double bond. If you have methyl ketone, that will definitely give positive iodoform test. Okay. Next you have pentane 3-one. Pentane 3-one is still possible. Let's talk about pentanol. Pentanol. Now if you talk about this thing, if you have CH3, C, this is OH and this is H. This also, this kind of alcohol which is secondary and which has methyl over it, that also gives the iodoform test, right? So now we have to choose between pentane 3-one and this, right? Okay. Now the other hint given to is the compound on reduction gives N-pentane. That means when you reduce this, it will give N-pentane, right? So after reduction, it is going to give directly N-pentane alkane. That means it should be pentane 3-one, right? Okay. So answer is going to be A is the correct answer. Got it? Okay, right? After the compound on reduction is giving you N-pentane over here, right? So answer is going to be pentane 3-one, right? Okay, chalo. And one more hint was there. The compound with molecular formula is form phenyl hydrazone. So whenever something is forming hydrazone, that means it has ketone. So this is also ruled out by that. Okay, na? Because it is showing us this kind of structure, that is NH2, this is Z. Whenever you have a compound that is having carbonyl group, it will give us This will be eliminated. It will give us C double bond NZ, and this is double bond over here, right? Okay, so that means here this is also ruled out. So answer is going to be A is the correct answer, right? Okay, understood this? Understood this, guys? Chalo. Next is the ionic reactions are generally very fast because it does not involve bond breaking. Ionic reactions, why they are very fast? The number of collisions between ions are very large. Reactions are highly exothermic. The energy of interaction between between charge particles, I think something is missing here, right? Okay, reactions are highly exothermic. The number of collisions between ions are very, very large. Okay, why they happens very fastly? Anybody in the comment section, right? Okay, the PDF will be provided to you in the description box. Okay, PDF will be provided to you in the description box. Yes, everybody, chalo. Very good, Samuel, if you solve JEE previous year questions, right? So answer is going to be ionic reactions do not involve bond breaking because they are existing as ions here. Energy is directly used in completing the reaction, therefore they are fast over here, right? Okay, so answer is going to be A, that is it does not involve bond breaking. Na and Cl, they exist as lattice structure like this. If you want to get into detail of this, they are existing as a lattice structure like this. They are not exactly bonded to each other. They are interacting with each other with with ionic interactions, negative and positive charge. Okay, understood? Chalo. Next question is match the following items, column 1 with column 2 that is given to you. Now these are the concentration terms, guys. So if you talk about molarity, you have to remember this by Virat. Okay, no Virat Kohli, no. So R, volume, V for volume, R for molarity, not litty, molarity. Okay, so that is number of moles of solute per liter of solution. ठीक है? Molality is number of moles of solute per kilogram of solvent. That is true. Normality is number of gram equivalents. That is also right because here we are talking about gram equivalents of solute per liter of solution. ppm is mass of solute and this. So your D is 1 over here. D is 1 over here. So these two are eliminated, right? A is 2, right? So answer is going to be A is the correct answer, right? Okay, chalo. Next is chlorine reacts with cold and dilute NaOH to give. Very, very important reaction, right? Chlorine reacts with cold and dilute NaOH to give which of the following? First, here they are giving you NaClO, NaClO3, NaCl, NaClO3, NaCl, NaClO, NaCl and NaClO4. So answer is going to be, as you can see the reaction, chlorine when it reacts with NaOH, it is going to give you NaCl and NaOCl plus water. So answer is going to be C is the correct answer, is it? Right? Chalo. Next, the incorrect statement about interstitial compounds. Okay. Yes. Incorrect statement about interstitial compounds. They retain metallic conductivity. They are very hard. They are chemically reactive. They have high melting. Why we need to make, we say that, okay, make interstitial compounds, or we also say make interhalogen, not interhalogen compounds, basically DNF block, we mix these compounds. What is the reason? Because the qualities are improved here. So answer is they are chemically reactive. Interstitial compound are obtained when small atoms like HBC resemble nitrogen, fit into the lattice of other elements. They are chemically inert. Right? So answer is going to be C is the correct answer. Next question is, the half-life of substance in first order reaction is 15 minutes. Rate constant. So directly it is a formula based question, right? Okay, T half is equals to 0.693 divided by K, right? So just put this value over here, right? Okay, they are asking you the value of rate constant, that is going to be 0.693 divided by T half. Okay, so just put this value here, right? T half value here and you will get the answer for K, that is going to be 4.62 into 10 raised to power minus 2 per meter. If they have given this in meters, minutes, right, answer is also in per minute. So you don't need to do any conversion here. Okay, no conversion is needed. Okay. Next is, which of the following does not give Cannizaro reaction? So guys, for Cannizaro reaction, there should be no alpha hydrogen here, right? Okay. For Cannizaro reaction, there should be no alpha hydrogen. So alpha hydrogen is, do not give. So this will give Cannizaro, this will give Cannizaro because both does not have alpha hydrogen. This also does not have, wait a minute. This is the alpha carbon. This alpha carbon does not have any alpha hydrogen. So this also gives Cannizaro. This is the alpha carbon. This is the alpha hydrogen. So this will not give Cannizaro reaction. So answer is going to be B is the correct answer. Is it? Yes, students. Okay. Next question is the conversion of alkyl halide to alcohol by aqueous NaOH. You have Rx, you have to convert it into ROH. Aqueous NaOH. It's a very, very famous reaction. It is a dehydrohalogenation reaction. Are you doing any are you taking out any hydrogen and halogen here? It is a substitution reaction. It is an addition reaction. It is a dehydration reaction. Are you taking water from here? No, right? We are substituting OH from here to this with this halogen here, right? So it is going to be B is the correct answer, right? Okay, why I am not using my this arm? Because beta, as you all know, those who don't know, I have some problem in this arm, right? Sometimes the problem appears in life, and usually in some important days only that problem appears in my life, right? So that's why I'm not able to write anything. That's why I am just showing you the slides here. I didn't wanted to cancel this. That's why the lecture was actually at 6 p.m. But I had to reschedule it because in emergency only I had to go to the doctor. And I didn't wanted to cancel it. So that's why I thought, chalo, I'll take the lecture at least because so many students are waiting out there. So I can't disappoint you like that, right? Okay, chalo. Which of the following methods of preparation of amines will give same number of carbon atoms in the chain of amines as in the reaction? Which of the following methods of preparation of amines will give the same number of carbon atoms in the chain of amines as in the reactant? Okay, right. So if you react this with the C triple bond reaction of nitrile with this, it will give you C triple bond N. So it will give it NH2. So that means it is going to increase. Just give me a second, beta. Okay. So it is going to give you CH2 NH2. That is going to happen over here, right? Okay. So that means one increment will be there. Treatment of amide with bromamide in an aqueous solution. So basically this is RCO NH2. It will give you the same number of carbons because it is going to give you RNH2. So the alkyl chain is going to remain the same. They are asking you give the same number of carbon atoms in the chain of amines as in the reactant. Chain having, though it is called the degradation reaction, but chain is having the same number, right? So I think the answer should be A, hai na? So answer will be A is the correct answer, right? Because it is going to give you the same number. It will vanish out, right? Here also it has R, it is having R plus 1. Here it is having R, here it is having R plus 1. Only in Hoffman bromamide degradation, alkyl chain will remain the same, right? Okay, understood? Chalo, answer is going to be A is the correct answer. Chalo. Next beta, next. Assertion. Okay. Primary structure of proteins give the idea about conformation of the molecules. Primary structure of the proteins. Okay. Primary structure of the protein give the idea about conformation of the molecule. The differences in chemical and biological properties in various protein arises due to difference in the primary structure, right? So basically, as you can see here, the primary structure of protein give only nature of linkages in the alpha amino acids, right? What kind of linkages you have, right? In the amino acid, how amino acids are linked to each other. That is the primary structure, right? How they are 3D bonded to each other, then you will have secondary structure, right? Like alpha helix, beta plated, right? So that is not right. R is the true statement. That is, the difference in this arises definitely due to the chemical bonding of this, right? Due to the difference in the primary structure. है ना? If you have different amino acid, definitely the properties of protein is going to be different. Na? Okay. Next is RCHO. You have three things. Cyclic ketones react with sodium bisulfite. Okay. Crystalline solid derivatives are formed when aldehyde or ketones are shaken with saturated aqueous solution of sodium bisulfite. So basically what we are doing here, you have this is the ion that we are talking about, right? So in addition, its addition is possible only under the condition of C double bond O, right? Which is definitely there in, right? Which is there in RCHO, RCOCH3 and cyclic ketones here, right? Okay, so answer is E is the correct answer, right? Okay. Shaken with saturated of the sodium bisulfite. Okay, so basically, both the answers are both are the true statement, and this is the correct answer for this. Why? If you put Y over here, why RCHO, RCOCH3 cyclic ketones react with sodium bisulfite? Because crystalline solid derivatives, right, are formed when aldehyde ketones are shaken with saturated aqueous solution of sodium bisulfite. That's why they are formed here, right? Okay, chalo. Next question is, aryl halide gives a mixture of orthopara product. Aryl halide undergo electrophilic substitution reaction more readily than benzene. Okay, what is electrophilic substitution reaction? When electrophile, electron-loving species will attack here, right? So when you have electrophilic substitution reaction, so basically if you talk about halogens are somewhat deactivating groups, but orthopara directing they are. Why? Can you tell me the reason behind that? I'll just write it here. Basically, what exactly happens here? It shows plus M effect. That's why ortho and para directing, because it has negative charge on the ortho and para position. But it shows also minus I effect. But here minus I effect dominates. It's the only case where minus I effect will dominate. That's why it is a deactivating group. That is the reason if you see here, aryl halide undergoes this more readily than benzene. No, that is a false statement. Reason being because this halogen is deactivating the ring here, right? That's why it will not be readily here. Okay, Ji, so answer is going to be A is true, R is false. Last is assertion reasoning, as you can see here. Last assertion reasoning. Last traces of moisture in ethanol can be removed by keeping it over sodium wire. So if you keep last traces of moisture on ethanol can be removed by keeping it on the sodium wire. Sodium reacts with water but not with ethanol to produce H2 gas. So as you can see here, last traces of moisture in ethanol cannot be removed by keeping it over sodium wire, and sodium reacts both with H2 and ethanol to produce H2 gas, right? Okay, so both the statements are going to be false over here. Okay, now let us come to the subjective questions here. Let us start the subjective questions. First question, as you can see on your screen, is what type of isomerism is shown by the complex? The complex is given to you, CrH2O6Cl3, right? So basically all the ligands are same here, right? So let us see. First thing, directly it is 3 marks question. Na? So as you can see, it will definitely not show any geometrical isomerism, cis trans like that. It will not show because water is the ligand. So it is going to show you the hydration isomerism. Okay, because the water can be outside the, it can act as counter ion, and this chlorine can act as ligand, right? Next is, on the basis of crystal wheel theory, write the electronic configuration of D4 ion when you have delta O greater than pairing energy. That means pairing will not be there, right? Okay, so you have to write it for the D4 configuration. So what exactly you are going to do here? For octahedral, you have 1, 2, 3, 1, 2. So what exactly you are going to do here? Okay, this is T2G, this is EG, right? They are saying delta O is great. Acha, pairing will be there, right? Can you tell me the reason behind that? Because if, for example, the shopkeeper is saying you need to give them 10 rupees, you give them 30 rupees, you have 30 rupees. That means you have the money to give them 10 rupees, right? Here you have, they are asking you just 10 rupees, you have 30 rupees. So that means you have extra money. You can cause a pairing here, right? Okay. So here answer will be 1, 2, 3 and 4. That is T2G4, right? Next is write the hybridization shape of COF6 3 negative. Now guys, here as you can see here, COF6 3 negative, right? Here it is x minus 6 is equals to minus 3, x is equals to plus 3, right? That means cobalt, which is basically, which is at 27, so it is going to be 4s2 3d7, right? So you are going to take away 3 electrons from here, that is going to be 3d6 here, right? Okay, so now there will be no pairing over here. 1 2 3 4 5 1 1 2 3, no pairing means it is going to be 1 2 3 4 5, right? And 6 will be here, right? So you will have sp3d2. Okay, the configuration will be sp3d2. Because of this, you will have octahedral, and that too outer octahedral shape here, right? Okay, ji. Chalo. Next is what is lanthanoid contraction? What is its effect on chemistry of elements, which follow the lanthanoids? Okay, lanthanoid contraction, I will tell you in simple manner, right? So basically, if you have positive, this is the nucleus which has positive, which is positive due to protons. Now this is the outermost electron. When these inner core electrons start shielding the electron from the nucleus, that is called shielding effect, right? Some will have good shielding effect, some will have poor shielding effect. Shielding effect of S is greater than P, then you have D, then you have F. In lanthanoids, you have F orbitals, right? So F orbital does not have good shielding effect, so they will not be able to protect the outermost electron from this nucleus. That is the reason because electron will be attracted, they will shrink. That is called contraction. That is called lanthanoid contraction, and it has so many consequences. The decrease in the atomic radii with increase in atomic number along lanthanoids are called lanthanoid contraction. The elements after lanthanoid closely resemble with the elements exactly above them. That means like hafnium and zirconium has the same radius, right? Can you tell me? Okay, for example, zirconium and hafnium have the same radius. That is the consequence of lanthanoid contraction, right? Okay, okay. Next is answer the following. Okay, okay, students, understood any problem till here, right? Okay. Any problem over here? Answer the following. For a certain reaction, large fraction of molecules have energy more than threshold energy. Threshold means activation energy, right? So if certain molecules have more energy as compared to threshold energy, they will be able to react, okay, and form the product. Yet the rate of reaction is very slow. Can you tell me the reason behind that, right? So basically what will happen here, though the reacting large fraction of molecules may having energy more than this, yet they may not be able due to the lack of proper orientation, right? Because three factors we have. One is collision frequency, other is activation energy, third is the proper orientation, right? So if they don't have proper orientation, that means they will not be able to form the products. Second is, state a condition under which a bimolecular reaction is kinetically first order reaction. Bimolecular means which has, for example, two reactants over here. Still we are saying the rate is this, A raised to power 1, B raised to power, but we are saying that it still is first order. That means one of the reactants should be in excess, okay? When the concentration of any of the reactant is taken in excess, then it is concentration is hardly changes, because if something is in excess, you're adding it, right? It hardly, if some, for example, it's like if someone is already billionaire, right? Millionaire, billionaire, so what will happen now? So they'll have just as a benefit of 2-3 crores. They will be like, okay, chill, what to worry. If someone like us, they have even benefit of 50 rupees or maybe 10,000 rupees, they'll be like, go crazy about it. Let's do party, because now today we had a profit of 500 rupees, right? So it's like that. If somebody, they already have excess of concentration, adding more concentration will have no change, right? So that is why the order of the reaction will be equals to 1 here, right? Okay. Okay, students, next question, as you can see here, the vapor pressure of pure benzene. Next question, guys. Next question is the vapor pressure of pure benzene at a certain temperature is given to you, right? Okay. Vapor pressure of pure benzene, that is here it is P naught B is given to you. A non-volatile solute, non-electrolyte solid weighing this much gram when added to this much of benzene. So this is W1, this is W2, right? Okay, molar mass of benzene is also given to you. That is M, pure benzene, a non-volatile mass. Acha, this is, wait a minute. Acha, this is M1 only. Okay. Vapor pressure of solution then becomes this. That means this is P. This is a partial vapor pressure. What is a molar mass of the solid substance? So you just have to apply here relative lowering in vapor pressure. So apply this here, relative lowering in vapor pressure here. That is going to be, I'll just write it down here. P naught minus P, P minus P naught divided by P is equals to mole fraction of 2. You can also write it as N2 by N1. You can also write it as W2 by M2. This is W1 divided by M1. Okay, understood? Okay, so what you have to calculate from here, everything, this is given to you, this is given to you, this is given to you, this is given, this is given, this is given. You just have to find this M2 over here, right, which you can easily found, and it will come out to be 170 gram per mole, right? Next over here you have calculate the osmotic pressure in pascals exerted by a solution, okay, exerted by a solution prepared by dissolving 1 gram of polymer of molar mass, this in 400. So basically osmotic pressure they are asking you. So pi is equals to CRT. What is C? This is number of moles divided by volume in liters. This is R and this is T, right? So osmotic pressure they are asking you by a solution prepared by dissolving 1 gram of polymer of molar mass this. So this will be W by M. This is V in liters. This is R and this is T. W is given to you, right? Molar mass of polymer is M is also given to you. This in, if this you put this in milliliters, then this will be multiplied by 1000 over here, right? If you put this in milliliters, right? This is also given to you. R value you already know, right? And temperature is also given to you, that is 37 degrees Celsius. So you just have to put the values here. Either you can convert the volume in liters, or you can just multiply that formula with 1000. That is totally your choice, right? Temperature, you know, number of moles is 1 by 18500 because mass is given to be that. In moles, you can easily calculate. Osmotic pressure, just put the values, put the value of R here, right? And you will get the answer, that is 31 pascals, right? Okay, understood? Better directly in board exams, directly they ask you the questions. Okay, in board exams, directly the questions are asked, right? You don't need to worry about that. That ma'am, oh my god, what they're asking, ma'am, I'm to gone crazy, ma'am. Okay, so directly they ask you the questions here. You don't need to worry about that, right? Describe how the following conversion can be brought about, right? So three conversions are given to you, right? Okay, let us see that. First conversion is cyclohexanol to cyclohexane 1-ol. That means from alcohol to you have to convert into ketone. That means one step oxidation is needed. So you don't need a very exhaustive oxidizing agent. So just using Cr2O3 in presence of H2SO4, you'll be able to convert it into ketone, right? Okay, so answer is going to be Cr2O3 H2SO4 in that is, it will convert it into double bond O, right? Then you have ethyl benzene to benzoic acid. Firstly, what you have to do, if you have alkyl over here, so any alkyl chain, okay, whether it's 10 number, 20 number, doesn't matter. When you add KMNO4 and heat it, it will directly be converted to COH, directly. Any alkyl chain you have, right, that will be directly converted. Then you have bromobenzene to benzoic acid. Now, bromobenzene, firstly, though, you have to convert it into benzoic acid. So, what we are going to do here, just directly add KMNO4 and heat it over here. Directly, this bromo will be converted to C double bond OH, right? It is that strong oxidizing agent, right? Okay. Next, students, we have calculate the equilibrium constant for, right, calculate the equilibrium constant for the reaction. This is given to you. Now you have to there are 2-3 formulas, okay, of physical chemistry, very important formulas, right? We will also do the revision of full physical chemistry, organic, inorganic, don't worry about it, okay? So basically here what you have to do, equilibrium constant E0 has a direct relation, okay? You just have to apply that formula here. So basically the relation, I'll just tell you the relation here, right? Okay, so this is the relation, okay? So how you got this relation? We got this relation from Nernst equation, that is E is equals to E0 cell minus 0.59 divided by N. This is log of Q. So if you put at equilibrium, this will be equals to 0, right? If this is equals to 0, so they will become equal to each other. So here answer will be, this will be equal to each other. So here answer will be, reaction quotient will become Kc. This is the relation. They are asking the value of Kc, or that will be log of Kc is equals to E0 cell multiplied by N divided by 0.059, right? Okay. Now, E0 value is E0 cathode minus E0 anode, right? E0 cathode minus E0 anode. Ma'am, in the question, you know, I always tell that in electrochemistry, the problem is you don't know how to apply the formula. Ma'am, we know the formula is E0 cathode minus E0 anode, but ma'am, we don't know what is E0 cathode and E0 anode. How to answer that? So here you can say it is increasing from 0 to +2. That means oxidation number is increasing. That means this is under oxidation. This is anode, right? And here oxidation number is decreasing. That means it is under reduction. That is, it is cathode. So you will use the reduction potential. This is also decreasing. This is also decreasing. Means both are reduction potential. You will use the reduction potential of cathode minus anode. This is cathode minus this. So 0.34, that's why we'll write here 0.34 minus of minus 0.763. That's how you get the value of E0 cell. Okay, once you get the value of E naught cell, you need to tell me what is the N factor here. Beta, because here also it is increasing by a factor of 2, it is decreasing by a factor of 2. That means there is exchange of 2 electrons here, right? So N factor is also going to be 2 here. Okay, N factor is going to be 2 here, right? Okay, put the values and you will get your answer over here, right? Okay, understood? Yes. Okay, next question is, consider a reaction from chemical kinetics. It is, they are saying consider a reaction, A2 products you have, K is given to you, calculate the concentration of A remaining after 100 seconds if initial concentration of A is this. ठीक है. Time is given to you, that means. Okay, K is also given to you. Calculate the concentration. So basically, firstly, you need to see where, yes. Beta, here they have not mentioned anywhere whether it's a first order, second order reaction. But we know that the units of K are mole per liter, 1 minus N per second. If N is equals to 1, only then it can be per second. Okay? That means the order of the reaction is 1. That's how you got the answer that order of the reaction is first order reaction. The first step for this. Okay? After that, you just apply this formula. That is this formula. Okay? Apply this formula. You have the value of K. You have the value of T, that is 100 seconds. They have also given the value of A naught, that the initial concentration is 1. You just have to calculate the value of log of this. Okay? If you put all the values here, put all the values, what you will get, log of A is going to be this. You just have to take the anti-log of this and you will get your answer. Okay? So everything is given to you. By this, can you see one thing over here? Can you see one thing, that calculation of anti-log and log, because in electrochemistry as well, in chemical kinetics as well, right? You have a lot of formulas of log, right? So 3 physical chemistry chapters you have, right? And in that, log calculation is very important. Log and anti-log calculation, right? Okay. Chal. Let's move to organic chemistry here. I think you will have 32 questions here, right? So give the major product that are formed by, major product guys, that are formed by heating each of the following ethers with HI. Ethers with HI you have to do. Okay? So let's try to answer it. Okay? First of 3 reactions we have, right? So if you talk about, they have directly given you this or what? So now they have given you the product here. Chalo, I'll just show you here. So basically what will happen here, this is CH2, CH this. Okay, this bond will break or this bond will break, right? So what you will see here, you will have the formation of H attached here and CH2 attached here. Can you tell me the reason behind that? Can you tell me the reason behind that? Yes, everybody, can you tell me the reason behind that? So the reason basically is, if none of them is 3 degree, okay, this is also not 3 degree, this is also not 3 degree. If none of them is 3 degree, then what will happen? This carbon is connected to one carbon, this carbon is connected to one carbon, right? So what will happen according to the steric hindrance factor, right? The halogen will get attached to less sterically hindered side, right? So less sterically hindered side is this I, and H will attach here. Okay? Hence you will have the formation of less sterically hindered alkyl halide. But very, very important question. Okay? It's also a very important question of competitive exams, right? Okay, not only boards. So what you will see here, this is 3 degree. Okay? This carbon is connected to 3 carbon. So if any of the alkyls, and very, very important point, beta, I am saying here. Very important point. Very, very, very important point. Okay? These are the questions of your NCRT. Okay? If any of the alkyl chain is not 3 degree, I negative, that means the alkyl halide, that alkyl halide will be formed, which is less sterically hindered. No problem in that, right? But when you have even one side, which is, I think it's JE question, ma'am, because I have done it. It's maybe they have asked this in JE, NEET also, in boards also. It's NCRT question exactly. Okay, I don't know if it's NCRT example or exemplar question. It is from NCRT only somewhere, right? So if you have any of it as 3 degree, then what will happen? You will use a carbocation here. That means that alkyl halide will be formed, which is more stable according to the carbocation. That is why what you will have the formation of 3 degree alkyl halide. Okay. Here you will use carbocation. Can you tell me? Because it is following SN1 mechanism. Here this is following SN2 mechanism. Understood? Here it is following SN2 because here no alkyl, no chain is 3 degree. When one chain is 3 degree, SN1 carbocation formation, that will be alkyl halide. Here beta, obviously when you have benzene, this kind of situation, definitely this bond will break. Here you will have alcohol I over here because phenol is definitely resonance stabilized. That is why definitely you're going to form phenol over here, right? Okay, chalo. Next question is, write the mechanism. Now, either kehta, they are saying either do this reaction or do this. Write the mechanism of following SN1 reaction. SN1 reaction means two-step. Two-step means carbocation formation. So, what you will have? Firstly, in carbocation, firstly breakup will happen. Okay? Firstly, what will happen? Firstly, beta, breakup will happen. Firstly, you will say tata bye-bye. Okay? Then only someone new will come to your life. Okay, so firstly breakup will happen, bromine will go, bromine will say tata bye bye, then you will be alone, it will be a carbocation, then you will have the addition of a nucleophile here. Okay, then a nucleophile will attack on the carbocation, right? Okay, okay ji, wait a minute, what is this? Wait a minute, let me see. Again they have written the same thing na, again same thing is written. So firstly what you will have the elimination of this. Here beta it will be Br. Okay, firstly this will be eliminated. Got it. Okay, I just got confused there that what exactly is written there. So basically carbocation, that is the first step, right? As I told you, there will be 2 steps after this. So basically 2 things can happen, that is racemization. Either nucleophile can attack from this side or from this side. This is what they have shown here. If nucleophile has attacked from this side, then this will be the answer. If nucleophile has attacked from this side, then this will be the answer. So basically a racemization will occur here. So mostly the product, slightly more inverted product is there, right? Okay, slightly more inverted product. Otherwise you can say it's not equal. Inverted and retention product is not equal. Slightly more inverted product you will see here, right? Okay, next question is, write the equation for the preparation of 2-methoxypropane by Williamson synthesis reaction. Beta dekho, Williamson synthesis reaction, it's also a very very important concept. Two reactions, HI and Williamson synthesis, both are very important, right? For your board exam, it's extremely important. So basically this is what you have to form. Now the question is, which will be RONA, which will be RX? Always remember, in alkyl halide, okay, in Williamson synthesis reaction, alkyl halide can never be 3 degree. It will be 1 degree. What I am saying, in Williamson synthesis reaction, in the formation, alkyl halide will be primary. Okay, so we have choose primary alkyl halide and 3 degree alkoxide. Okay, 3 degree alkoxide we have choose. After that, you will have the formation of the desired product. Got it? Okay, I am also writing here. Alkyl halide never always 1 degree, always primary. ठीक है, in Williamson reaction always alkyl halide is primary. ठीक है जी, चलो next question is arrange the following compounds in the increasing order of the property indicated. Reactivity towards HCN, then you have acidic strength, then you have boiling point. Okay, reactivity towards HCN. Beta, how does HCN will react? This is also acetaldehyde. Basically, it's like this. Okay, this is benzaldehyde. I'll tell you what exactly they're asking. Acetophenone. Acetophenone is this thing. Okay. Then you have acetone. Acetone is. So basically, what is HCN reaction? What exactly happens in HCN? What exactly happens in HCN? Can you tell me the answer here? What exactly happens in HCN? This is H positive, this is H positive, this is Cn negative, right? What will happen? Negative part will attack here, electrons will jump here. Okay? Negative part will attack here, electrons will jump here. If I want this negative part to attack here, if you want to give someone the money, that means they should be electron deficient. Okay? If you call Ambani, hello Ambani, I have 1,000 rupees in my piggy bank. Yes, you need it. Ambani will be like, what? Hello, excuse me. Isn't it? But if you give the same rupees, you have 1,000 rupees, you think that okay, some poor person out there who is not able to eat anything, you give them just 10 rupees ka samosa, they will be so happy. You give them 5 rupees biscuit, they will be so happy. Hai na? So it depends on the deficiency, whether they need it or not. Now that means I have to check the electron deficiency over here. Here you are providing the electrons from one side. Here you are providing the electrons from two sides. Here, this benzene is basically, tell me one thing, this is providing the electrons from this side. Here what you are doing, this C double bond O beta. Now always there is one more concept that when you on the benzene, you have a compound, a group which is attached to double bonded to more negative element, then it will take out the electrons from here. So basically this is going to take out the electrons. That means the electrons are going to shift here. Here also the electrons are going to shift here. I want less electrons. The minimum electrons I can see is in acetaldehyde, isn't it? Minimum electrons, guys, I can see in acetaldehyde. So can I just write it over here that the minimum electrons I can see in acetaldehyde? So answer will be maximum deficiency of electrons is in acetaldehyde, right? It will show the fastest reaction that I am poor, please give me money, right? I am poor, please give me money, right? Here it is getting electrons from plus I and plus I effect, so they will be like, okay, I am also poor but not very poor in life, right? I am also poor, he is also poor but not as compared to this. So after that you will have acetone. Okay, after that you will have acetone. Now between this and this, here you are taking money from benzene. Here you are taking money from benzene and CH3 both. So here you have sabse amir banda, like very rich person. So it will not take money from outside, right? So that is why after this you will have benzaldehyde, then you will have acetophenone, because acetophenone is very rich, is very satisfied with their life, right? Okay, understood. So this question is done. Next question here is arrange this in acidic strength. Beta, arrange this in acidic strength. Can you tell me how to arrange this in acidic strength? Anybody in the comment section? Acidic strength, beta, again we are going to see the stability of carbocation, right? So basically this is C, this is CH3, this is CH3, this is H, this is COO negative. This is CH3, this is CH2, this is CH positive, and this is COO negative, right? Okay, this is CH3, this is CH positive, this is CH2, this is COO negative. Beta, now tell me which carbocation is maximum stable. Negative. Can anybody tell me negative means stress or money? Those who have studied from me, they know what I'm talking about. Negative means beta stress or money. Negative means stress or money. Negative means stress. Okay, so when you give stress to someone, somebody is already in stress, you give more stress to them, they'll be unhappy, it's unstable, right? We need to see the stability. Here you are directly, this is array, what I have written, why I have written H here. ओहो गड़बड़ हो गई, CT बच गई. Okay, so this is CH2, this is Br, ठीक है, this is Br over here. I don't know why I have written C over here, I think by mistake. चलो, ठीक है. Now what you can see here, here you are providing the electrons with plus psi and plus psi effect, right? Okay. Here you are giving the electrons, right? But here you are also taking the electrons from Br. Here also you are taking out the electrons. So when you are taking out the stress, right? Here you are two distance away. Here you are just one distance away. If your friend is just near to you, next to your house, they are taking out the stress, right? They are talking to you. They are like, okay, don't worry, everything will be fine, right? If somebody is long distance, right? And then they are talking about this and that, they are saying, don't worry, I am here, but still they are not there, right? So basically, it's that distance, long distance, it's not long distance, right? So this will be more stable. So answer is going to be, answer is going to be, answer is going to be, this will be the maximum stable because the distance is less. Okay, Br is going to show minus I effect here. Here also Br is going to show minus I, but the distance is more. Here there is no Br, so here answer is going to be nothing, right? Okay, so it is going to have minimum stability. Next is CH3 CH2OH CH3 CHO CH3 COH, boiling point. देखो बेटा, boiling point is basically dependent on the force of attraction. So we all know that in ethanol, so you have a very strong force of attraction, right? If you talk about three things here, this is C double bond OH. Here it is C, O and H. Here it is C double bond O and this is OH. So this will form a dimer. Okay? This will form a dimer, and dimer due to hydrogen bonding is even stable than the hydrogen bonding. So this is going to have maximum force of attraction than ethanol. Here you don't have hydrogen bonding, right? Because hydrogen is not directly connected to any electronegative element. So answer is going to be, this is the correct answer, right? Okay, chalo. Next question is, on half cell in a voltaic cell, you have a voltaic cell, right? Okay, is constructed from a silver wire dipped in silver nitrate solution of unknown concentration. Other half cell consists of zinc electrode. There are two half cells. Okay, one's half cell is voltaic cell is constructed of silver wire dipped in silver nitrate solution. Unknown concentration it is there. Other half cell consists of zinc electrode in this much of ZnS. Hello, 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 hello. Oops, I'm so sorry, beta. I'm so sorry. Wait a minute, let me see. Okay, I don't know how it got disconnected. Beta, now is it audible? Oof, oof, oof. Now is it better? I think the battery got low. For mic, the battery got low. That's the reason. Chalo, no worries. Okay? Acha. Now let us see this. Now let us see this. Now in my whole class, I'll be in a panic state. Okay. Now, here as you can see, which has more reduction potential? Ag. That is why more the reduction potential, that will be reduced, right? So that is why this is cathode and this is anode. Okay, once you know this is cathode, you just have to subtract this value from this value. Okay, subtract this value from this value. This is E naught cathode, this is anode. So you will get to know the value of E naught cell. E cell is already given to you. So we'll just apply the formula of Nernst equation, that is this. It is E cell minus E naught cell minus 0.059 divided by N factor. N factor, as you can see, this is getting converted Zn2 positive to Zn. Okay, this is getting oxidized, so this will be Zn2 Zn2 positive. Okay, loss of electrons, 2 electrons. Okay, from Ag positive, it is getting reduced to Ag, right? Here you have addition of 1 electron, but this will be multiplied by 2. Okay, that's why it is multiplied by 2. Can you tell me why it is multiplied by 2? Because number of electron lost and gained should be same. Now after adding, what you will get? Zn plus 2Ag plus 2Ag positive give rise to 2Ag plus Zn2 positive. Okay? So always it is oxidation by reduction or products by reactant. This is product, this is reactant. So it will be Zn log of Zn2 positive, log of Zn2 positive divided by Ag positive ka square. Why square? Because here stoichiometry is this. Okay? But just give me a second. Hello. Hanji. Yes. So now here you can see this is oxidation by reduction. That is, this is the oxidation part divided by reduction part raised to the power the stoichiometric coefficient here. That is how you use the equation, right? Zn2 positive is given to you, that is 1 molar. So I'll just put the value here. that Zn2 positive is 1 molar. Okay, so I'll put everything here. You will get the value of log Ag positive that you have to calculate here. Right. So basically what you have to understand that log of 1 by Ag positive of square is equals to, you take it as log of, this is the important part here, log of Ag positive raised to power minus 2. This minus 2 will come to the front side, so it will be minus 2 log of Ag positive. This is what they have written here, minus 2 log of Ag. Okay? Okay, rest of the things are simple calculations only. Right? Okay? Okay, understood? Which question you want me to repeat? Which question you want me to repeat, beta? Yes. Which question you want me to repeat? This one or which question? ठीक है जी? चल. Understood na? Again, I'll just repeat it. So basically, one half of the cell they are saying is this. Other half is this. ठीक है? They are asking you to find the concentration. ठीक है? So basically, we'll just apply the Nernst equation here. For Nernst equation, E naught is given to you. E naught cell you can easily calculate by E naught anode minus cathode. How to find anode and cathode? That you can find from which has more reduction potential. That will be cathode side, right? After that, they are saying that this is also given to us. This is product by reactant. So this is given to us as 1. This is what they are asking you to find out. Okay? Rest of the things are calculation part, right? Okay, this one is better nothing. Here you have dimerization. COH always form dimer. How it forms dimer? C double bond O. This is OH. This is C, a double bond O. This is OH. This is how a dimer will be formed, right? Okay, this is how a dimer will be. Acha, aise nahi. It will be formed by this connecting by this and this connecting by this. A dimer will be basically formed here, right? If you talk about COH, you will have the formation of hydrogen bonds here. Here you don't have any hydrogen bonds. So more the interaction, more is the force of attraction, more is the bonding, more is the boiling point, right? Okay. Chal. Next question is, one of the two figures here, okay, two figures are given to you, represents substitution and other represents elimination. Indicate in which is substitution, which is elimination. Very, very simple question here, right? Okay, very, very simple question, beta. Very, very simple question. As you can see here, okay, in the A figure, what you can see, what is happening here, you have CH3. There is attack of CH3 on this side. Br is leaving, right? You have the formation of, okay, two figures given represent substitution and other represents elimination. Here what you have, here you have CH3, CH2O, okay? And here, this is leaving and this bond is shifting here, okay? Okay. One is substitution, one is elimination. Ma'am, break. Beta, we are just left with 5-6 questions. What's the point of break? Okay, you don't need any break. In exam, you will ask for break. Okay, so basically represents elimination because in this anion attacks H and simultaneously Br leaves, leading to the formation of a double bond here. Okay, how you can say that? Anybody? This is leaving, this bond is getting shifted here, right? And this hydrogen, it is also getting shifted to this particular compound, right? Now, here what you can see, basically represents substitution as nucleophile attacks the compound and simultaneously leaving groups leave. So here what is happening, here what is happening, this nucleophile is attacking here, right? And this group is leaving to this side, right? Okay, so that is the substitution reaction. Okay? Okay, next question is, wait a minute. What is the electrochemical series? How does it help in calculating EMF of the standard cell? These kind of questions are only asked in board. not in any competitive exams, right? Okay, so what is electrochemical series? The series of elements which have been arranged on the basis of their electrode potential, specifically reduction potential. Okay, is called electrochemical series or activity series. Second question was, how does it help in calculating EMF of the standard cell, E naught cell? E naught cell is equals to E naught cathode minus anode, right? So directly you can write the equation here, and that too we are talking about the reduction potential, not the oxidation potential. Once you know the reduction potential, this we have done this na? In past 2-3 numericals we are doing this thing only, right? Chalo. Now next question is, read the following text. Okay, ma'am, that's an interesting thing. Okay, let's see. 1 2 3 4 5 5 questions we are left with, which are big questions. Okay, 5 questions beta we are left with. These are big questions, so you need to have full concentration over here. Read the following text carefully and answer the question that follows. The transition metal when exposed to oxygen at low and intermediate temperature. Okay, transition metals when exposed to oxygen, when you expose them to oxygen at low and intermediate temperature, forms thin protective oxide film up to some thousands of angstroms in thickness. Okay, transition metals. Transition metal oxides lie between extremes of ionic beta. What I would advise you in the exam, okay? This I am not going to read out this and then check this. In the exam, how you will do it, I'm going to do it in the same way. That's the benefit of solving the paper with me, है ना? Then what you will get, but then what you will get over here, okay? Okay. Yes, Samuel, what is the doubt? You can tell me, है ना? You can tell me your doubt in the comment section, okay? Okay, you can tell me what is the doubt in the comment section, right? Okay, chal. Now, firstly, we will see the questions here. Okay, why does copper, which is in the first series of transition metal, exhibit +1 oxidation state? Let us try to firstly, if you know, is transition exhibit +1 oxidation state more frequently. I don't think so. You even need to see this full paragraph here. Reason why we know. Why? Because +2 oxidation state is more stable. Copper readily loses 1 electron from its 4s to form more stable 3D electronic configuration, because it is 4s1 3d10. Okay? After losing it will become 3d10. Okay, so that's why Cu positive will exist here. Right? Okay. Next question is, the lowest oxide of transition metal is basic. Why? Firstly, let us see. Transition metal oxide lie between extremes of ionic and this, formed by atoms left to right side. They range between metallic to semiconductor and deviate from both small degrees. D electrons level are involved. The cations exist. Okay, we can't see. The crystal, we can't see our answer here. Okay, we have to answer ourselves. That's why I'm saying that in the exam, don't read the paragraph firstly. Firstly, read the questions, right? Then read the paragraph, whether you can see the answer over there. The lowest oxide of transition metal are basic in nature. Can you tell me the reason? Because whenever you have lowest oxides, the lowest oxide, basically acidic character is directly proportional to the oxidation number. Right, more is the oxidation number, more is the acidity. Less is the oxidation number, less is the acidity. Lower oxide has low oxidation state. This means some of the valence electrons of the metal atoms do not participate in the bonding. They can donate electrons and can behave as bases. What are bases? Right, which can donate the electrons. Right, like Lewis bases, the ions, lone pairs. These are the bases. Right. So in the lower oxidation state, they have enough electrons to be donated, right? Okay, that's why. Okay, these means some of the valence electrons of metal atom do not participate in the bonding, right? They can donate electrons and can behave as the basis, right? Next question is, the variability in oxidation state of D block different from that of P block. Beta, D block is different from the P block. Can you explain the variability in oxidation state? Basically, what exactly happens here in D block, there is variation of 1 1 1 1 oxidation state. In P block, there is large oxidation state gap. Okay, So in P block, lower oxidation state is more stable due to inert pair effect, whereas in D block element, higher oxidation states are more stable. In D block, oxidation state differ by 1, whereas in P block, they differ by 2. Okay? Here low oxidation state, there high oxidation state, here it differs by 1, here it differs by 2. But these are theoretical questions. Crystal structure of oxides of transition metal often show defects. Okay? Wait a minute. This actually question will not be there. Okay? Because this is not in your syllabus. I'll just not answer that. Right? So you don't need to do that question. Okay? Now, next question is attempt any of the 5 of the following. Okay? Any 5 of the following you have to attempt. Which is the structural feature characterizing reducing sugar? So this is basically from Biomolecules, this full is, right? So again, polysaccharides, DNA, beta complex, disaccharide, name purines present in DNA. So all of these are basically your one word question, right? Summed up, and you just need to answer one. That will become 5-mark question. Okay. What is the structure feature characterizing reducing sugar? So first is that reducing sugar have free aldehydic or ketonic group. Okay? They have free aldehydic and ketonic group. They can reduce Tollens reagent. Okay? Next is what type of linkage is present in polysaccharides, right? So glycosidic linkages are present in polysaccharides, even in disaccharides, right? Next is give example of fat soluble vitamins. So that is KEDA. Okay, you have to remember KEDA, KEDA. Okay, vitamin K, vitamin E, vitamin D, vitamin A. Right, these are fat soluble. Next question is two strands you have DNA are not identical but are complementary. Explain that. Two strands of DNA are not identical. The helical structure of DNA, two strands are held together by hydrogen bonds between specific pair of bases of purines and pyrimidines. So basically, like A is bonded, hydrogen bonded to T, G is hydrogen bonded to C, right? A has 2 hydrogen bonds, G has 3 hydrogen bond with C, right? Cytosine form hydrogen bond with guanine, adenine form hydrogen bond with thymine. As a result, two strands are complementary to each other. Understood? A is hydrogen bonded with a double bond, G is hydrogen bonded with a triple bond. Okay? This also we have done. What are the uses of B complex? Right? It is required for making red blood cells and muscles. Beta, B complex, what is the uses? Okay? Definitely vitamin B deficiency. I have that, है ना? That's why facing a lot of issues in life. Okay? So, next is name the disaccharide which on hydrolysis give 2 molecules of glucose. So, which is formed from glucose only? Which is that disaccharide? That is maltose. Okay? That is formed from glucose. After hydration, it is going to give the same monosaccharide, that is glucose. Right? Next is name the purine present in DNA. In DNA, what are the purines? Purines, they are asking you the purines. So purines are A and G, adenine and guanine. These are the purines that are present. Basically, these are the bases that are purines that are present in the DNA. Right? Okay. Next question here is the IUPAC name. Everybody, let us see that here. But that's how they will ask you the questions, okay? In the exam also, that's how they will ask you the question, okay? Because it's a 5-mark question. So that will be mostly from one chapter only, if they ask you that. Write the IUPAC name of the following coordination compound, right? Okay? Chalo. You have to write down either solve this or solve this one. That is option. Okay? So you have to write down the IUPAC name of these. So here what you have to do, these are the ligands. Firstly, write the ligands in the alphabetical order. This is amine, nitro and chlorido and platinum over here. So answer is going to be, I'll just write down from this thing only, right? So IUPAC name of this particular is diamine, 2-amine, chlorido. After that you will have chlorido, then you have nitrido, and that too because nitrogen is connected here, right? So it will be nitrito N. Then you will have platinum here. Why? Because the center metal atom is neutral, right? It is not negative, so directly you will write platinum. And the oxidation number you will calculate x plus 0 minus 1 minus 2 is equals to 0. So x is going to be 3. Okay? So here it is going to be, wait a minute. Acha, there is 1 NO2, na? 1 NO2. Okay. So x plus 0 minus 1 is equals to 0. X is equals to 2. Okay. So answer is going to be x is equals to 2. What about this one? What about this one? Here it is minus 2. So it is going to be x. This is 3. So it should be minus 3. So it will be x minus 6 is equals to minus 3. X is equals to plus 3. Okay. So here it will be plus 3. Because this bracket, this coordination sphere is negative, it is an anion. That is why the central metal atom will have 8 after the name. So it will be chromate, not chromium, right? Okay, that is the difference. Next is, okay, potassium, because it is a counter ion, potassium, trioxylato, it is oxalato, trioxylato, chromate 3. Okay, that is also done. Third one is, you have ethylene diamine here. Okay, this is minus 1, this will be plus 1, so it will be x minus 2 plus 0 is equals to plus 1, right? It will be x is equals to plus 3. That is why in the bracket they have written plus 3. Now, this is ethylene diamine. This is bis ethylene diamine. Why bis? Whenever you have di, tri, tetra in the ligand name, then you write it bis, tris. Okay? So it will be bis, where it is, bis ethylene diamine or ethane 1,2 diamine, right? E, before E you have C. Okay? A, B, C, D, E, right? So it will be dichlorido, bis ethane 1,2 diamine, cobalt 2, and the counter ion is chlorine, so it will be chloride, right? Next is, here you have CO3, okay? Again, you just have to calculate it. This is minus 1, this will be plus 1. CO3 minus 2, because CO3 is exactly minus 2, so it will be x minus 2 is equals to plus 1, so x is going to be plus 3. Okay, because CO3 is a negative ligand. CO3 minus 2, carbonate, that is the ligand, right? Carbonato it is called, right? So here it is going to be plus 3. That is why over here in the bracket you have plus 3. Now let us name it. It is amine and it is carbonato, right? So amine will be first. So it will be pentaamine, carbonato, cobalt is 3. Then you will have chloride. Right? Chalo, last one. Hg and this is SCl. Now, beta, what you have to do, this is plus 1, so this will be minus 1, right? So, x plus 0 is equals to minus 1. So, wait a minute. Plus 1, this is minus 1, na? Okay. Let me just write it here. X. This is SCN thiocyanide minus 1. So it will be minus 4 is equals to, this is plus 1. This will be minus 1. Okay? Because here Hg is not in the it is not in the mercuric state. It is in the mercurous state. Okay? So it will be plus 1. It will be minus 1. So it will be minus 1. So it will be x 4 minus 1. X is equals to 3. Okay? So this cobalt will exist in plus 3 oxidation state. Okay? So here if you write it, this Hg is in the mercurous state. So it will be either you can write mercurous or you can write mercury 1. Okay? Mercury 1, this is tetra thiocyanato. Thio is for sulfur. Cobalt. Now it will be cobaltate because coordination sphere is negative. So it will be cobaltate. And here X oxidation number we are finding it to be plus 3. Right? So answer is going to be this. Right? Okay? Understood? Acha. That is also done. Next is valence bond theory. Explain the following in relation to the paramagnetic complex. Beta, paramagnetic complex means there is no pairing. ठीक है, no pairing. Firstly, तो MnCN, this is going to be x minus 6 is equals to minus 3, x is equals to plus 3. Mn, we know it is 25, Karman. Okay, so it is 4s2, 3d5. You take out 3 electrons here, you take out 3 electrons here, it will be 3d4. Okay, there will be no pairing they are saying. So this is D. 6 ligands you have here. That means it should be either sp3d2 or d2sp3. This is 5, this is S, this is P. They are saying no pairing over here. So it is 1, 2, 3, 4. Right? Either you can have d2sp3, but D you can't have over here. Right? So here what is going to be here? It is going to be sp3d2, because at least 2d you need to have. You are saying it is paramagnetic, that means there is unpaired electrons here. Beta, but wait a minute, explain the following in relation to the paramagnetic complex. No. Because this is a strong field ligand, na? Strong field ligand. So strong field ligand will have the pairing. Okay? Paramagnetic this will be, but it will have the pairing. How it will have the pairing? If you talk about the 4 electrons here, paramagnetic in relation to the paramagnetic magnetic moment value, type of complex, inner outer octahedral. Wait a minute, this is weird, little bit weird this is. Reason I'll tell you. Because this is a strong field ligand, this is a strong field ligand, है ना? But they have given us that this is paramagnetic complex. Okay? That means there should be unpaired electrons. So what we will do? 1, 2, 3. After that 4 should be over here. But if you put the fourth electron here, what will happen? This 1d orbital will be empty. We don't want that. So what we will do here? This 4th electron will be over here. So that it is d2sp3, that is inner octahedral complex, but it is paramagnetic also. Now this Cn has caused the pairing here, it is paramagnetic also. Okay? So here what we can say, that sp hybridization is d2sp3, it is a inner octahedral complex, magnetic moment is 2.8 something. Why? Because it has 2 unpaired electrons here. Right? Okay, so that is a very, very, very important thing regarding this. So directly beta, you can say, you can apply this formula also, that is mu is equals to under root n plus 2. You can put the value, solve this, but I would say just write in the exam, just write this formula for the examiner, that you know the formula. After that, if it is 1 unpaired, so it will be 1.7. 2 unpaired means 2.8. 3 unpaired means something 3.8. 4 unpaired means 4.9. 5 unpaired means 5.9. Okay? This much it is going to be. Right? Okay? Okay. Now, next question is, write the structures of major product. Write the structure of major product when benzene disonium chloride reacts with the following. So, very, very interesting question. A and B. Let us see this. HBF4 with heating, Ball-Schiemann reaction. CO and HBr, this is Gattermann reaction. So both are the naming reaction. Mostly in exam, if they ask you from organic chemistry, mostly the questions will be predictable. Okay? Nothing as a new reaction they will ask. Okay? So question will be predictable. This is Ball-Schiemann reaction. Okay? After this Ball-Schie, she is doing color. Okay? So she is doing fashion. Fashion means F. Right? So this N2Cl will be eliminated and you will have the formation of fluorobenzene, that is Ball-Schiemann reaction. With copper powder, when you have powder, whenever there is gutter, there is powder. So what will happen? This will be replaced by Br because you have added HBr. If you add HCl, this will be replaced by Cl. Okay? Okay. Next question is write the structure of ABC in the following reactions. So you have to write the structures here. So firstly, you have nitrobenzene. Adding SCN, SC, HC, SN, HCl, tin HCl. So what will happen here? This will be reduced to NH2. After adding NaNO2 HCl at 0 to 5 degrees Celsius, there will be diazotization. That means it will be converted to N2Cl. After adding water here, and when you warm it, right, then this will be converted to OH. But in case of alkyl disonium chloride, alkyl, that means if you have RN2Cl, even at 0 to 5 degrees Celsius, okay, what will happen? This will be converted to ROH. But in aryl disonium chloride, you need to increase the temperature, you need to warm it, right? Okay, done. Next is, I think B part is given to you. You have KCN. KCN means this will be converted to CH3CN. Then you have to reduce this, convert it to CH2NH2. Then you have to add NH2 and at 270 Kelvin. So HNO2 diazotization again you are doing. Okay, chalo. CH3Cl means this is CH3CN. This is converted to CH3CN. Now C triple bond N, these two pi bonds will break. This will be converted to CH2NH2. Okay? Acha, that is converted to CH2NH2. After that, either they can tell you it's NaNO2 plus HCl. Beta, either it is written NaNO2 HCl or it is written HNO2. Both are the same thing. We are doing a diazotization. Okay? So it will be CH3, CH2OH. This is the same thing. Reason is this. Why? As I told you, if you have benzene disonium chloride, it will be converted to disonium chloride. After warming, it will be converted to OH. Here, without warming, it will be converted to OH because alkyl disonium chloride is not at all stable. Okay? Understood? These two reactions are very important. Okay? Chalo. Next is, acha, there is some OR part also. Dekho, full on paper we are doing. Okay? OR part also we are solving. I think this is the last question. Last question this is. OR part also we are doing here. Let us see the OR part. Illustrate the following reaction giving suitable example in each case. Ammonolysis, coupling reaction, acetylation of amines. Three very, very important reactions we have here. Let us see one by one. First is ammonolysis reaction. Ammonolysis means when in the alkyl halide you are adding ammonia. Okay? That means excess of alkyl halide excess of ammonia you are adding here. So what will happen? Firstly, you will have NH3 and RX. So you will have the formation of 1 degree. Okay? That means you will have the formation of 1 degree amine. Then after adding more of RX, you will have the formation of 2 degree. After adding more RX, you will have the formation of 3 degree amine. After adding one more RX, you will have the formation of quaternary salt. That is ammonolysis, right? Next is coupling reaction. Basically, it is azodite test, right? So if you have with the example they are saying, so what exactly happens here? You have disonium chloride, benzene disonium chloride. If you add aniline, what will happen? From the para position H and this Cl will be eliminated. This will join together, couple together, and this will have the formation of this kind of azodite. So when you talk about aniline, it is going to give you yellow color of dye. Yellow color. Talking about when you have phenol, it is going to give you orange color dye. Okay? In phenol, instead of NH2, you will have OH here. That's the only difference. Okay? That's the only difference you will have. Okay? Third is acetylation of amine. So basically in acetylation, you add CH3CO group. So let's say they are talking about amines here. Okay? They are talking about amines here. We are going to do acetylation. So for acetylation, either you add acetyl chloride or you add acid anhydride. What I am saying? Either add acid chloride or acid anhydride. Okay? So here what will happen? This Cl and this H will be eliminated. You will have CH3, CH2, NH, and here you attach COCH3. ठीक है. So here you will have the attachment of CO. Instead of this NH, you will have the formation attachment of CO CH3. That is acetylation. ठीक है. Other examples are this. देखो 3 degree amine will never show acetylation because for acetylation you need to have a hydrogen on the nitrogen. ठीक है. So this hydrogen and this Cl will be eliminated. You will have the formation of this COCl, COCH3 instead of this hydrogen. Then you have aniline. ठीक है. Now beta again what will happen? This Cl and this hydrogen here will be replaced. And instead of that hydrogen, you will have the formation of COCH3. That is basically acetylation. 3 examples we have seen here. ठीक है जी? Okay. अच्छा. Next question, what they are saying. This also we have done. Next is describe Heisenberg method for the identification of primary, secondary, tertiary amines. Also write the chemical equation involved. It's a very, very simple question. Heisenberg reagent you have. 1 degree, 2 degree, 3 degree, how they will react. Let us see. Very, very interesting and very simple, frequently asked question, okay? Frequently asked question for your board exams, right? So basically what is there, what we have here, the reaction of primary and secondary amines with benzene, okay? So basically, beta, this is C6H5SO2Cl. This is Heisenberg reagent. So what will happen here? This HCl will be eliminated, okay? And this will attach together. You will have for the primary amine, in the product also on nitrogen you have 1 hydrogen. That means this is soluble in alkali. Alkali is NH4OH. Here also eliminate this hydrogen from here, attach them. Here on this nitrogen, the hydrogen that you have is, it does not have hydrogen. That means this will be insoluble in alkali. 3 degree, in 3 degree, you will have R. There is no hydrogen that this benzene, benzene sulfonyl chloride can take away, right? So that means this will not react only. 1 degree, it will give the product that is soluble in alkali. 2 degree, which is insoluble in alkali. 3 degree will have no reaction. So that is how you distinguish between 1 degree, 2 degree and 3 degree amines here, right? Okay. Okay ji. ठीक है जी. Done. So guys, that's it for today. That was the paper for you. Okay? Yes, everybody. So that was the paper for your PU board exam, right? And if you like this session, if you want more of such sessions, then do let me know in the comment section here, right? I would love to guide you. If you have any problem, you can tell me in the comment section what exactly are your queries regarding chemistry PU board exam, right? Okay. Very good. 79.1% in J by watching your cheat code and all sessions. Thank you. Amazing, Rohan. Amazing, Rohan. Awesome, awesome, awesome. Okay, I'm so happy for that. Thank you, Kiran. Thank you, beta. PDF beta, that will be provided in the description box after this lecture. By tomorrow morning, that will be updated in the description box. Okay? Yes. Chalo. Okay then, bacha. Bye-bye. Take care. See you all in the next class. Till then, take care of yourself and just keep studying, right? If you have any problem, you can always talk to me on Diksha Kaushal Chemistry Official or Diksha__Kaushal on Instagram, right? Okay, bye-bye. Take care. Phase 2. Beta, that will be updated on JE channel, right? Okay, Ganesh? Yes. Okay, bye-bye. Bye-bye-bye.